Okay, let's dive straight into this explainer and unlock the examiner's absolute playbook for mastering Cambridge AS and A-level mathematics. Specifically, we are zooming in on syllabus code 9709 today. Whether you're building your mathematical foundation from the 0580 or 4024 syllabuses, or you're stepping up from the rigorous 0606, 4037, or 4040 additional math tracks, what we're covering right now is the ultimate bridge to advanced analytical thinking. Today, we're focusing on one of the most notoriously tricky yet fundamentally beautiful areas of the entire A-level syllabus, complex numbers. I want you to think of this topic like navigating by the stars. If you understand the key command words and the core mathematical framework, you can chart a direct, foolproof course to those top marks. We are going to deconstruct the exact strategies, the hidden pitfalls, and the specific analytical mindsets that separate average, middle-of-the-road responses from absolute perfection. Because, look, this isn't just about memorizing formulas from a textbook. Honestly, anybody can do that. This is about understanding exactly how the Cambridge examiners think, what they're actively hunting for with their red pens, and how they grade your paper under intense pressure. So grab your notebooks, get totally focused, and let's decode the secrets of syllabus section 3.9 together. Take a look at this. This is a crucial quote directly from a senior Cambridge examiner, and it should immediately grab your attention. It's a real game changer. Mastering the Cartesian form of complex numbers is literally your golden ticket to the highest grade boundaries. Now, you might be wondering why this specific topic. Why not calculus or trigonometry? Well, because complex numbers aren't just an isolated standalone topic. They are a profound test of your logical processing, your algebraic stamina, and your ability to apply totally abstract concepts to completely unfamiliar contexts. The massive jump from a B grade to an A star doesn't come from simply knowing what a complex number actually is. It comes from an absolute bulletproof mastery of presenting, manipulating, and evaluating these numbers under strict timed exam conditions. When examiners see a student effortlessly handle Cartesian coordinates with precision, it signals a high-level mathematical maturity. It tells them, hey, this candidate knows exactly what they are doing. Here is our masterclass blueprint for today's explainer. We're going to break down the challenge you face, the core principles you need, the top examiner warnings, the all-important method mark strategy, a high-speed interactive workshop, and finally, the final system you'll use on exam day. Let's get into it. To really understand the challenge, we need to look at two very typical candidate profiles facing a real Cambridge mathematics past paper question. Let's call them Alex and Sam. Now, Alex is incredibly smart. Alex literally knows every single formula in the 9709 syllabus backwards and forwards. But when faced with a multi-step complex number problem, say finding the square roots of a complex number, Alex panics and overloads the exam paper with raw mathematical facts without any structured analysis. There's algebra everywhere, no clear logical flow, and the examiner is left helplessly hunting for the actual answer amidst a giant sea of unorganized numbers. On the other hand, we have Sam. Sam completely understands the math, maybe even better than Alex. But Sam rushes through the answers, completely missing the specific requirements dictated by the command words. If a question specifically commands an exact value for an argument or a modulus, and Sam just aggressively punches it into the calculator and gives a rounded decimal approximation, Sam loses the marks. It's that simple. Both of these students are dropping incredibly easy points, not because they don't know the underlying math, but because they completely lack the strategic exam technique required to present it effectively. So, how do we fix this? Let's move to our first major concept and build the theoretical architecture required to ace this topic. Now, what's really interesting about this slide is that these precise definitions and strict causal relationships are the absolute foundation of your exam success. To stop being an Alex or a Sam, we have to start right here at the foundational bedrock, building a concrete fortress of knowledge. The Cartesian form is expressed as X plus IY. It looks so simple, right? Just a couple of letters. But here is where the true analytical depth comes in, and where so many candidates mess up. The X represents the real part. The Y represents the imaginary part. But notice something absolutely crucial here. Y itself is a purely real number. It is simply the real coefficient of the imaginary unit I. So if you have a complex number like 3 minus 4i, the real part is 3, and the imaginary part is negative 4. It is not negative 4i. When you are sweating through a rigorous 9709 past paper, treating the real part and the imaginary part as distinct, independent, real-valued components that can be equated across an equal sign is the master key to solving the most complex algebraic puzzles. If you blur the lines between x and y, or if you carry the I into your simultaneous equations by accident, the entire methodological framework of your answer completely crumbles. And the Cambridge syllabus heavily emphasizes that top-performing A-star candidates don't just memorize that X plus IY formula.
Instead, they actively reference cross-topic connections and apply this conceptual understanding to completely unfamiliar contexts. This is the massive difference between having isolated generic knowledge and true integrated mathematical thinking. For instance, when you see x plus iy on your paper, you shouldn't just think of a flat, boring algebraic expression. A top-tier student instantly connects this to coordinate geometry. They are automatically visualizing the real part x on the horizontal axis and the imaginary part y on the vertical axis of an Argand diagram. They're instantly connecting it to trigonometry when thinking about converting this Cartesian form into polar form using the modulus and the argument. Examiners write these 9709 questions specifically to see if you can pull knowledge from entirely different areas of the syllabus to solve a single unified problem. It's like a giant puzzle, and complex numbers are the pieces that tie algebra and geometry together. So how do we present this beautifully on the page? Let's look at the Peel framework. Point, evidence, explanation, link. Now, I know what you're thinking. Isn't that for English or history essays? No way. It is incredibly powerful in mathematics for structuring complex, multi-stage calculations. Let's say you're finding the square roots of a complex number. Make your point. State your mathematical principle clearly, like writing down that x plus I y squared equals the given complex number. Provide the evidence. Expand those brackets meticulously on the page, showing the examiner exactly how I squared becomes -1, and group your real and imaginary terms beautifully. Provide the explanation. Explicitly show where you equate the real coefficients to form equation 1 and the imaginary coefficients to form equation 2. And finally, link. Solve the simultaneous equations and link your calculated x and y values back to state the specific roots requested by the original question. Before we continue to see exactly how top students use this to avoid disaster, subscribe to our YouTube channel Ace the Exams Act, Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's pivot to the friction points. We need to look at the examiner warnings to understand exactly what not to do. There are exactly 3 massive recurring mistakes that examiners see candidates making year after year after year. When grading tens of thousands of papers, the senior markers notice incredibly specific patterns. Despite teachers warning students constantly, these 3 specific errors just keep showing up, and they are completely destroying candidates' chances of reaching that top A-star grade boundary. Let's break them down meticulously right now so you are absolutely guaranteed not to make them when you're sitting in that exam hall. Warning number 1. Students forget the proper format for Cartesian form. They'll do all the hard math but leave their final answers in messy, unseparated fractions rather than a clear, distinctly separated x plus iy. Warning number 2. Failing to check presentation. Your working out must follow strict conventions with crystal clear steps and distinct substitution. If an examiner can't follow your logic, they can't award you method marks. Warning number 3. Providing generic answers that totally lack specific context. If the question asks about a specific geometric transformation on an Argand diagram, and you give a purely algebraic answer without mentioning that specific translation or rotation, you will immediately lose the final accuracy marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. To really visualize this, notice how the flawed generic answer on the left of the screen totally ignores strict mathematical conventions. It's just a jumble of floating numbers that fails to separate the real and imaginary parts clearly. It's chaotic, and it inevitably leads to deduction marks, those dreaded red pen marks all over your paper. In stark comparison, look at the transformed answer on the right. It uses proper headings, correct mathematical terminology, and clear annotations linked directly to the scenario. The top candidate has explicitly stated equating real parts and equating imaginary parts before writing their equations. The logical flow is absolutely undeniable. The math might be the exact same underlying calculation on both sides, but a systematic, evidence-based presentation actively guides the examiner to award full marks. You are essentially holding the examiner's hand and showing them exactly why you deserve an A-star. Now that we know exactly what pitfalls to avoid, let's unpack the absolute best weapon you'll use to defeat these tricky questions: the method mark strategy. This systematic processing sequence is your method mark strategy. What does that mean? It means ensuring you are awarded points for your mathematical process even if your final calculation is slightly off due to a silly arithmetic slip. Step 1. Extract relevant data. Pull out the exact complex numbers and constraints given in the prompt. Step 2. Select the analytical framework.
Ask yourself, are you multiplying complex conjugates? Are you finding a modulus? Or are you equating coefficients? Step 3, execute with clear notation. This is absolutely crucial. Use your X's and II distinctly and carefully. Step 4, verify your results. Does the geometric location of your answer make logical sense on an Argand diagram? Step 5, present correctly in the requested format, whether that's exact Cartesian form or rounded polar form. If you systematically followed this sequence, you lock in the method marks every single time, acting as a massive safety net for your grade. I highly recommend using this simple mnemonic during your exam to instantly recall the steps needed to deconstruct any complex question. It's a true memory hack, ISEVP. Identify, select, execute, verify, present. When you open that exam booklet and the adrenaline is pumping and your mind suddenly goes blank from nerves, I want you to quickly write ISEVP at the top of the page. It grounds you. It literally forces your brain to slow down. Identify what the complex number problem is actually asking for. Select the absolute right algebraic formula. Execute the algebra flawlessly, line by line. Verify your arithmetic by doing a quick mental check. And finally, present it in the beautiful X+iy Cartesian form. It's such a simple psychological hack, but it fundamentally organizes your cognitive process when you're under immense time pressure. Okay, let's dive into an interactive workshop right now. Get ready, because you have exactly 60 seconds to scan a complex data set and spot the precise sentence in a sample paragraph that loses marks for poor presentation. Imagine a student has written a solution trying to find a complex conjugate. They've done all the algebra, and at the very bottom of the page, they boldly wrote, "The answer is 3 minus 4. The 60-second timer is officially running. Scan that concept in your mind right now. Look at the data. What is the fatal flaw in that sentence? The answer is 3 minus 4. Think about the core principles we just discussed. Think about the distinction between real and imaginary parts. We're down to 30 seconds. Are you catching it? Is it a calculation error or a presentation error? 10 seconds left. 3, 2, 1. Time's up. The fatal flaw, of course, is the totally missing I. The student wrote a purely real expression when the context explicitly demanded a complex format. The correct answer should be 3 minus 4i. Even though the number 4 is the correct imaginary coefficient, forgetting to attach the I completely changes the mathematical meaning. Identifying these tiny, seemingly insignificant flaws in practice actively trained your brain to never, ever make them on the actual exam day. To truly secure that A-star, we have to elevate our answers beyond just basic calculations to demonstrate higher-order critical analysis. Top-scoring candidates demonstrate evaluative thinking by constantly questioning assumptions, comparing different approaches with comparative connectives, and justifying their mathematical decisions with hard evidence. Let's break down these 3 levels. At the basic descriptive level, you're just stating facts. You just state that X is real and Y is imaginary. It gets you started, but it doesn't get you the A. At the analytical level, you actually use that fact to solve an equation by equating the coefficients on both sides of the equal sign. That's solid B-grade territory. But at the evaluative level, the A-star territory, you might be mentally comparing the Cartesian approach to a polar coordinate approach for a specific complex problem. You justify to yourself why Cartesian form is actually way more efficient for addition and subtraction operations, but recognize instantly that polar form is vastly superior for dealing with multiplication, large powers, and roots. This demonstrates a holistic, masterful grasp of the entire mathematics syllabus, and examiners absolutely love to see that level of fluency. And this pie chart brilliantly illustrates how the Cambridge assessment objectives target these distinct cognitive domains, proving once and for all that raw knowledge alone isn't enough to secure all the marks. Knowledge and understanding, just memorizing the formula, only makes up one slice of the pie. The exam heavily weights application. That means taking your foundational knowledge of complex numbers and actively applying it to a brand new geometric or algebraic puzzle that you've never seen before. And finally, the analysis and evaluation slice demands that exact higher-order thinking we just discussed. If you only memorize the textbook, you're actively ignoring 2/3 of the entire grading criteria. You have to train all 3 slices of this pie. Let's bring all of this together into your ultimate cheat sheet. This is the Exam Strategy Masterclass. Students who actually implement these 3 specific mathematics strategies see an average improvement of a massive 2 grade boundaries. But, and this is a big but, that only happens if they practice consistently with our weekly explainers. Rule 1, command word decoding. You must always identify if the question asks you to show that, evaluate, or solve. Each of those specific words demands a completely different level of algebraic rigor and proof. Rule 2, Peel framework application. Structure your multi-step complex number proofs logically so the examiner can effortlessly follow your argument. Rule 3, the time management matrix. Allocate your exam time strictly based on the marks available. Do not spend 10 agonizing minutes on a simple 2-mark Cartesian conversion. Consistent structured learning is literally the only way to internalize these A-star strategies. By applying this system week after week, you are refining your technique and mastering the syllabus. Your A-star is entirely within reach, but it requires serious commitment to the process. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, _IGCS, to excel in your Cambridge examinations. Subscribe right now to @the_IGCS and click that bell. Don't let another exam pass you by without having the best possible strategy in your corner. Drop a comment below with your target grade for mathematics and the biggest challenge you're currently facing. Seriously, let us know. Our team responds to every single comment. Like and share this video with a study partner who needs to hear this. Ace the Exams. Your Cambridge success starts here. So I leave you with this final provocative question. When you sit down to write your very next complex numbers answer, is it going to be a messy, generic data dump like Alex? Or will it be beautifully structured and strategically linked to the specific context to guarantee every single mark? The choice is entirely yours. Until next time, keep analyzing, keep evaluating, and keep aiming for the top.